Hi everyone, today we're looking at how we can analyze velocity on different types of graphs. So what we're going to be looking at initially is how we can find velocity from a position time graph. So if you recall, when I have a position time graph, if I want to calculate the velocity, what I would have to do is I would have to find the slope of the line. So I'd have to find the change in the y, so in other words the displacement or the change in position, and I would take that change in position and divide it by the change in time. So this would be my change in time on the x-axis, so the change in x, and that would give me my slope, and my slope is equal to my velocity. So the slope of a position time graph is velocity. And we looked at that a little bit in detail in the previous set of videos looking at position time graphs. What we can do is we can take velocity and actually make something called a velocity time graph. So I have a velocity time graph, and I can simply look at the velocity of the object and plot it on a graph. So what we have in your workbook are several examples of velocity time graphs for objects undergoing different kinds of motion. So again, it's important to remember that when we're dealing with velocity graphs, we have velocity on the y-axis. You really have to check your axes just to make sure that you know what graph you're dealing with. That's not a position time graph, it is a velocity graph. Now, velocity graphs, as I said, clearly, easily indicate your velocity. They tell you right there, like you can read directly off of the graph. So for example, for vehicle A or object A, you can see that at the beginning, at 0 seconds, the velocity is 0. At 1 second, the velocity is 0, 2 seconds it's 0, 3 seconds it's 0, and 4 seconds it's 0. So in other words, during this entire time, the velocity of this object is 0 meters per second. In other words, it's motionless. We can describe this object, A, as being motionless. It has no velocity. So I'm just going to emphasize that. So the velocity is 0. Quick reminder, when we deal with velocity, we use the symbol V with the arrow on top, the vector symbol on top. Okay, let's look at vehicle B now. Now B, the object at 0, is moving. It's moving at 4 meters per second north. At 1 second, well, it's still moving at 4 meters per second north. At 2 seconds, it's the same 4 meters per second north. 3 seconds, 4 seconds is moving at 4 meters per second north. So we can say that the motion is constant. We have a constant velocity that's not changing. So we can write down here, we have a constant velocity of 4 meters per second north. In other words, we have here an example of uniform motion, motion that is not changing. Now vehicle B has motion that's northward. C is similar, except now, if you look at C, at 0 seconds, the object is moving at -1 meters per second north. In other words, it's moving southward. Remember, negative here is south, opposite of north. At 1 second, it's also moving at 1 meter per second north, or south, sorry. At 2 seconds, it's 1 meter per second south. 3 seconds, 4 seconds, at both times it's moving at 1 meter per second south. So we can say here we've got a constant velocity. So again, constant velocity of, in this case, 1 meter per second towards the south. Again, it's uniform motion in this situation. D and E are a little bit different because here you can see that the velocity is not constant, it's actually changing. So for D, you can see that initially it has a velocity of 2 meters per second north, and then very quickly it has a velocity of about 2.5 meters per second north, 3 meters per second, 3.5, and finally 4 meters per second north. So in other words, my velocity is becoming more northward. So we say that we've got an increase in the velocity. An increase in velocity is called acceleration. So here I have an acceleration northward. We're increasing our velocity towards the north. So I can write down here, I've got a acceleration, so the object is accelerating. and it's changing its motion such that it's increasing the velocity towards the north. So it's accelerating northward. And we should write down what it's doing. So it's from 2 meters per second north initially, and to the final velocity of 4 meters per second north at the end of the time interval we're looking at. So I should give a little bit of a description there. Now E, it's a little different now. E, what happens is we're going from a velocity of 4 meters per second north at 0 seconds to a velocity of 0 meters per second right here. So in other words, we're coming to a stop. So we're moving northwards, coming to a stop. We must have a southward acceleration, therefore. So remember, when we're stopping, the acceleration of the object is opposite to the direction of the original motion. So originally moving northward, so therefore the acceleration must be southward. And if we continue our acceleration, we actually see here that my velocity is increasingly becoming more south. So we have a higher velocity towards the south. So what we can write down over here in the description is that my object is accelerating southward from a velocity of 4 meters per second north initially to a velocity of 2 meters per second south at the end of the motion. So again, you can see it's very easy to describe the motion of these objects just by analyzing the velocity, reading it right off the graph. You don't have to do any calculations whatsoever.